students, welcome back. In this part of video we are going to discuss about universal law of gravitation and the measurement of gravitational constant G. We know that G is not explained by Newton, it is explained by Henry Cavendish. So in this part of video we will show you a experimental video and let's continue. Hello students, welcome back. Now I am going to continue part 2 of gravitation. Now we are going to start universal law of gravitation. Universal law of gravitation. Universal law of gravitation is defined by Newton's. According to Newton, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That is, force of gravity is proportional to mass of object 1 and also proportional to mass of object 2 and inversely proportional to the distance between the two masses and the square of that. So the proportionality constant is here, the proportionality constant is G. So according to Newton, F is directly proportional to m1, directly proportional to m2 and inversely proportional to square of distance between them. So F is proportional to m1 into m2 by r square. So here we are introducing a proportionality constant. So F is equal to G. Here G is the proportionality constant. So F is equal to G m1 m2 by r square. Here F is the gravitational force, m is the mass 1, m2 is the mass 2, r is the distance between the center of the masses. G is equal to 6.7 into 10 to the minus 11 Newton meter square per kg square. This is the unit. So keep in mind the unit of G, gravitational constant. Here G is called universal gravitational constant and the unit of G is Newton meter square per kg square. It is important, it may be asked in competitive examination what is the unit of G, gravitational constant, the unit of gravitational constant, and also they may ask the dimension of universal gravitational constant. So keep in mind value is also important. So G is equal to 6.7 into 10 to the power minus 11 Newton meter square per kg square. Here F is equal to G m1 m2 by r square. Now here there is two body m1 and m2. So as I explained earlier in part 1, the gravitational force is attractive in nature and the r is the distance between them. So here the direction of F1, force on mass 1 due to m2 is towards m2 and force on mass 2 due to mass 1 is towards m1. So and the magnitude and the value of F1 is equal to F2 is equal to G m1 m2 by r square. Only here F1 and F2 are equal in magnitude but opposite in direction. So now also acceleration due to gravity Z0 is equal to force. We know that F is equal to ma. We know that F is equal to ma. So we want to find acceleration. So force is divided by mass. This will give acceleration. The same thing is here. We are introducing G0 as acceleration. May be represented by A or G, but we are here introducing G0 as an acceleration. So this is the acceleration due to gravity. So now divide this. F is equal to G m1 m2 by r square. Now if you want to find acceleration, you have to divide this value by mass. So the rest part is G0 is equal to this G and this m, or this is r square. So here m is the mass of earth, r is the distance between the two bodies, or this is maybe the radius of the earth. So g naught is the acceleration due to gravity, and the value is gme by re square. So this is also important formula, so keep in mind. Now the next topic is universal law of gravitation. Universal law of gravitation. We are continuing universal law of gravitation. Now the previous one is F is equal to g m1 m2 by r square is a scalar form. This is they are only we are finding in terms of magnitude, and manually we are showing the direction of the force. Okay, but now we are trying to find the force in terms of vector. Okay, so force in form of vector we are trying to derive. So force, now this is same thing. Here m1 is the mass 1 and m2 is the mass 2, and mass 1, this is the F12, is can be read as force on mass 1 due to mass 2, F12, and F21 is the force on mass 2 due to mass 1, and r is the distance between them. Now here let us consider this is a coordinate system xyz, and there are two bodies here, bodies A or body 2. There are two masses of mass m1 at point A in the coordinate system and mass m2 at point B in the coordinate system. So r1 and r2 are the respectively, r1 and r2 are the position vector of mass 1 and mass 2, and r12 here, r12 is the displacement vector BA. So r12 is equal to r1 minus r2. So F12, what is the direction? This is the mass 1 and this is the mass 2. Now we are trying to find force on mass 1. F12 can be read as force on mass 1 due to mass 2. This is the vector F12. So here we are trying to derive this formula. So F12, first we have to write this in scalar form. So F12 is equal to g m1 m2 by r square. Okay, now in the vector form, if you want to write in vector form, so F12 vector F12 is equal to, can be written as F12 unit, this is the magnitude, into unit vector. So unit vector, what is the unit vector? F12 is in direction of A to B. So here we can write this as AB, unit vector of AB. Okay, so F12 is equal to magnitude into, any vector can be expressed as magnitude into unit vector. Okay, so here F12 is the magnitude of the force between these two masses due to gravitation, and AB is the unit vector representing the direction of the force. So now vector AB can be written as F12 vector AB, unit vector AB can be written as R21 unit vector. So this can be written as F12 R12 unit vector with negative sign, since R12 unit vector is equal to negative of R21. Okay, so R12 is in the direction of A to B, B to A, so R21 is in direction of A to B. Okay, so now F12 vector can be written as, put these values of magnitude of F12 from here. So minus G M1 M2 by R. Here R is equal to, R can be written as R is equal to R12 magnitude of R12 or magnitude of 2 R1. So put this value here, so we can write this here. R, we can put anyone, so we are putting here R12 in form of vector in terms of magnitude and then square. Now put this unit vector, so R12 unit vector. So this is the final formula written here. So keep in mind, force on 1,2 is equal to minus G M1 M2 R12 square into unit vector. We have to just multiply. This is the value of the magnitude of the force, and this is the direction. Here negative sign comes due to opposite direction, since here force F12 and displacement R12 is in opposite direction. So this is due to this, here minus comes. Now here F is the gravitational force between mass, here F is equal to gravitational force of mass 1 due to mass 2, here F12, okay, and M1 is the mass 1, M2 is the mass 2, R is the distance between the center of the masses, and G is equal to 6.7 into 10 to the power minus 11 Newton meter square per kg square. So this is the vector form of universal law of gravitation. Now we know the scalar form of the universal law of gravitation, and also we know the vector form of universal law of gravitation. Now further proceed. The next topic is measurement of gravitational constant G. In previous slide, F is equal to minus G M1 M2 by R square into unit vector. So in terms of magnitude, F is equal to G M1 M2 by R square. So how to find G? What is the G and where it comes from? So actually F is equal to G M1 M2 by R square is given by Newton's, but even Newton doesn't find the value of G. The value of G is found by Henry Cavendish, an English scientist, physicist and chemist. He found this value of G, universal gravitational constant, and now I am going to explain how Henry Cavendish find this, measure the value of gravitational constant G. So let's continue. Measurement of gravitational constant G can be explained as, this is the crossbar PQ, it is rotated and two balls are metallic rods, two light rods and metallic rods. Using these two metallic rods, C and D masses are suspended, and R and S, using R and S, two small masses are suspended using light rod, and a crosshead, using crosshead PQ, a torsional head and torsional wire suspended, explains the PQ, RS and AB. So now this is closed. Measurement of gravitational constant can be explained as, here using cross rod is suspended, a PQ, cross rod PQ is suspended from the ceiling, and using metallic rod C and D, two masses are suspended, and also using RS, two small masses are suspended, light rod, using light rod, and using torsional wire and torsional head it supports the, it can be explained as using crossbar PQ, two masses are suspended from the ceiling. Now using this tool it rotates, and mass PQ and this RS are in a straight line. RS is suspended using this torsion wire and this torsion head. Now PQ, light rod, RS and AB. This is the system which explains the measurement of gravitational constant. Now this is two telescope is used to explain this system, and this is closed to avoid any error. Now we rotate this PQ, and now this is balanced. It is rotated in such a way that PQ, this PQ is perpendicular to CD. Now at its crosshead it is adjusted so that there is no torsion in this crosshead. Now again it is rotated. So here, now here A, C, B, D. Here A and C attracts each other and B and D attracts each other. Due to this attraction, there is a torsion in this rod, and this can be explained at an angle theta. So now it can be calculated using this. I am going to derive this in the next page, so you will see in the next page in the details. So this is the setup, this is the pictures of this video. Here this is the torsion wire, this is the heavy mass CD, and this is the smaller mass AB, and after rotation of theta, this is the new position of this AB. Okay, and the length of this AB is 2L, and the angle between this rotation is theta. So now go to the next slide. So let M be the mass of each small sphere. So mass of the small sphere is M, small m. So and the AB, okay, AB, and capital M will be the mass of each big sphere CD, and R be the distance between these A and C or B and D. So it is a straight line rod, so if it rotates from one side at R angle, so other side also it rotates at R angle, and the length of AB is 2L. AB or RS both are in same length, so it is 2L, and C is the, let C is the restoring torque per unit angular twist for the material wire. This is the wire for twisting. Now we know that we have to find it. Let us just explain in other words. So this is the AB mass, okay, and other two masses, big masses, are C and D. So due to rotation, this rotation angle theta, due to this rotation there is a torsion in this wire. So now we are going to find torsion in this wire, and also torque, restoring torque due to due to attraction between these two forces, due to gravitational force, and we are going to compare these. So now we know that the force of attraction between AC is equal to G m1 m2 by r square, and we know that torque is equal to force into distance. Okay, so twisting torque due to gravitational force of attraction, twisting torque due to this force of gravitational force of attraction is G m1 m2 by r square into, what is the distance, is 2l, so 2l. Okay, now restoring torque due to torsion in wire, and now we are going to find restoring torque due to torsion wire, this wire. So C into, what is the rotational angle, is theta, C theta. Now compare equation 1 and equation 2. Compare equation 1 and 2. So Gmm by r square into 2l is equal to C theta. From here we can find that G is equal to C theta into r square by small m capital M into 2l. All these value, small m, capital M, length L and R are already known. Theta can be measured using vernier, and C is already known, restoring torque per unit angular twist of the material, it is already known. So everything is known, so we can find this G, and the value will come 6.7 into 10 to the power minus 11 Newton meter square per kg square. So unit of G is Newton meter square per kg square. Dimension is mlt minus 2, this is the dimension of force, and L2 dimension of m square, and this is the kg minus 2. So this can be simplified as m minus 1 L3 power and t minus 2. So this is the dimension of G. This is important, so keep in mind. Now we are going to solve this question. Now AG is equal to BG is equal to CM. Here this is a triangle ABC, equilateral triangle. This is an equilateral triangle. So since all the sides are equal, and this is 2 meter, so AG, this is AG, BG and CG. These three side distance between the masses are equal, and it is 2 meter. So we have to find what is the force acting on mass 2m placed at centroid G of the triangle. Now we have to find the how much force acting on here G. So we have to find, here the system has 4 masses, so we have to find force due to mass at A, mass at B and mass at C at G. So we know that for gravitation is the attractive in nature, so we can solve that. If G, force on G due to A is equal to G m1 m2 by r square, is equal to 2, this is r square, and what will be the direction? This will attract here upper direction, so it's J cap. So now find FGB. FGB, it will attract like this. So your angle, how much this angle? This is 30 degree. So GM 2m by 2a square, and this is minus I cap cos 30 minus j cap sin 30. Similarly, find FGC. GC is in direction this, and this is the 30 degree. So GM 2m by 2a square, and this will be I cap cos 30 minus j cap sin 30 degree. Now we have to find the force, net force acting on this mass 2m. So F net is equal to F FGA plus FGB plus FGC. Now just solve it. So what will be the value? Gm into 2m by 2a square, this part will be common, and here j cap minus I cap cos 30 minus j cap sin 30 plus I cap cos 30 minus j cap sin 30. Here these two parts will be cancelled. Okay, so now finally G2gm a square by 4 in the bracket j cap minus j cap by sin 30 is equal to 1 by 2. So this is, now finally this will come cancel 2, and it will like gm square by 4, gm square by 4 and j cap. Okay, this will give j by 2. So this is the final force acting on, this is the force, resultant force at G. So net force at G will be in upward direction at J. Okay, and the magnitude is gm square by 4. Now the second part is, this is the first part, the second part is, what is the force if mass at the vertex is triple? So this is the 3 times, so this will be only FGA will be changed. So for second part only FGA will be changed, other part will be same. So mass is 3 times, so just replace it. This m is replaced by, here now m is replaced by 3m, so here m is replaced, so m 3m into 2m by 2a square j cap. Now put this value here and solve it. F net. Okay, this will give second part. Only we have to do that, we have to replace GA. Okay, now next part. Two small bodies of masses 2 kg 4 kg are kept at rest at a separation of 2m. Okay, here this is the mass 1 2 kg and the other one is at here 4 kg. Okay, kept at separation of 2m. So this is the 2 meter length. Now where should a third particle of mass 0.1 kg be placed to experience no gravitational net gravitation from this body. So now let us consider we are putting this third particle of 0.1 kg here at distance x from 2 kg. Okay, so now what will be the distance? This distance between 0.1 kg and 4 kg is 2 minus x. Okay, now we have to, since gravitation is attractive in nature, so on this new body, force due to 4 kg will be in this direction and force due to 2 kg will be in this direction. So force is in opposite direction, and for net balance, so for no net gravitational force, we have to equate these two forces. Okay, so now we are going to find force. We are going to equate force on 0.1 kg. Let us consider this is A, this is B, and this is C. So force on C due to A is equal to force on C due to B. So now G, M1 is 0.1, M2 is 2 by x square is equal to G, M1 is 0.1 into M2 by R is 2 minus x whole square. Solve it. So 2 minus x by x whole square is equal to 2. So 2 by x minus 1 . So 2 by x minus 1 is equal to root 2 plus minus. So 2 by x is equal to plus minus root 2 plus 1. So x is equal to 2 by 1 plus minus root 2. Solve this value and negative value x is equal to 2 by 1 minus root 2 or x is equal to 2 by 1 plus root 2. This is the negative value, so rejected, and this will be the required value. So this is the answer. Okay, now this is the second part of gravitation. We will continue third part. Stay tuned with us. Thank you. So student, we have discussed about universal law of gravitation in the form of scalar, magnitude, and in the form of vector. And we have also discussed about measurement of gravitational constant G. In the next part, we are going to discuss about gravitational potential and gravitational field. So stay tuned.